Thanks for joining Mastering Jump to learn about sentiment analysis, which is, as we'll see, related to two new features in Jump Pro 16. So I do want to say right off the bat, this is a Jump Pro topic, and these are new as of version 16, which just came out officially in March. So let's first just talk about what sentiment analysis is and why you'd want to do it. And then we'll walk through two different methods of doing it in Jump. So first off, what is sentiment analysis anyway? Sentiment analysis is all about quantifying positive or negative sentiment in unstructured text data. So that is freely generated text that may convey some sentiment or some emotional content. And we want to quantify, how positive or negative that is. And as I just mentioned, we're going to look at two different approaches for doing sentiment analysis in Jump Pro 16. But let's just boost our intuitions right off the bat with what sentiment analysis is practically and why it might be useful. Here's the first data set that we are going to work with. These are reports from the US Federal Reserve Bank Board of Directors. It's reports called the Beige Book, which is published 8 times a year by each of the 12 districts of the Federal Reserve. So we can see them listed in rows 1 through 12 here. I can highlight them. There we go. So Atlanta, Boston, Chicago, and so forth. And the reports themselves are based on qualitative information like interviews with local business leaders. And the Federal Reserve Boards of Directors then give their outlook for the economy. So here in the first report we have, which is all the way back from 1970 in May, we can see the very first sentence here. The mood of our directors varies from pessimism to optimism. These reports contain a lot of kind of emotional, if we want to call it that, emotional language, like these words pessimism and optimism. And so we might want to actually quantify how positive or negative these reports are to get an idea about where the economy might be headed. And so that's what I've done in this report right here. So this is in Text Explorer in Jump Pro 16. And as you'll see, we have one of the new features we're going to look at, the sentiment analysis tool. And I'm going to walk through all of this in detail. So I'll just summarize what we're looking at right now. We have the overall distribution of positive and negative sentiment across all a little over 5,000 reports in this data set. Orange is positive, and that purple color is negative. So we can see that our distribution leans positive, which makes sense. The US economy has, in this time period since 1970, often done pretty well, though with some periods of recession in there. You can see down here, for each of the documents in our data, we have, among other things, an overall sentiment score. So this document that we're looking at right now has a score of -20, and that's on a -100 to 100 scale, where -100 is maximally negative sentiment and +100 is maximally positive. And here's a more neutral document with a -1 score and so forth. And we're going to get into all of the details about where these scores come from, how to calculate them. But let's first just think about how to use them. In this case, we might want to quantify sentiment in something like the Beige Book to get an idea of how we think the economy might do in the future based on some expert opinion. And so I was actually curious when looking at these data, how well these sentiment scores tracked with economic events or indicators. And one of the things I looked at was sentiment over time from 1970 until late 2020, which is the last report I've included in the data. We can actually see sentiment going up and down. So the gray dots there are the sentiment scores of the individual reports. The blue smoother, kind of, you can think of it somewhat like the average across time. And the red regions there represent periods of economic recession. And one of the interesting things you find here is that reliably, a year or two before a period of recession, you can see that the sentiment across these Beige Book reports tends to start dropping, which means that maybe Beige Book sentiment here is a useful leading indicator of recessions. It's also curious about the geography. So we have these 12 different regions here, and different economic events impact regions differently. And it looks like the sentiment of the Beige Book tracks with that as well. So here I have a map. We're sticking with the same color coding we saw in the report. So orange is positive sentiment, that purple color is negative, and gray here is 0. So we're looking at the 12 Federal Reserve districts across 3 years, 1999, 2000, and 2001. And if you're thinking historically, you might remember this was the time of the dot-com bust, when many emerging internet-based companies on the West Coast started to go under. And we can actually see, say, from 1999 to 2000, we see sentiment in the San Francisco region of the Federal Reserve rising and then plummeting as we move into 2001 when the bust took place. So sentiment seems to track both across time and geography with respect to the dot-com bust. Or if we go ahead a little bit to, let's say, 2007 to 2012, around the Great Recession, you can see the impact of the initial collapse of the housing market and then the subsequent economic reverberations. So New York in 2008 and the West Coast were hit particularly hard, as was the southeastern US, especially Florida, the state that I call home currently. And something that I found particularly interesting is that as you watch things start to recover from 2010 to 2012, the recovery was known to actually be a little bit slower in Florida than in other places. And you can kind of see that here as we go from 2010 to 2011. We're staying more neutral in the Atlanta region that includes Florida, and then not kicking into positive sentiment until we get back to 2012 there. So I highlight that just to show you some of the ways that you might be able to work with some sentiment scores that you can derive from some text data that you have available. They might really carry some important or interesting information. So this is just one possible use case that you might imagine. There are a number of use cases for sentiment analysis. A big one is in consumer research. So whether you're looking at product reviews or maybe consumer surveys and wanting to quantify how consumers feel about maybe your product or service. Similarly, in brand management, looking at maybe media coverage or social media posts around your brand, being able to track how positively or negatively people feel about it across time. You can apply sentiment analysis to product improvement efforts. Maybe you have something like warranty claims and you want to see what elements in the claims might be pointing to things that are particularly frustrating for your customers so that you can target those for improvement. Plenty of people use sentiment analysis in customer support. Maybe you have call centers, you have call logs or transcripts. You might be able to use sentiment analysis to identify calls that result in a particularly happy or not so happy customer so that you can figure out what may have driven that. And then the domain we just looked at, public policy, trying to figure out how people feel about maybe proposals of laws or other policies. And that's kind of where we're going to stick today, in part because publicly available data is a little easier to get our hands on. So we're going to stick with this beige book data set for now, but then we'll get into another public policy data set in just a little bit here. So let's move on and actually talk about these two different methods that I've mentioned for conducting sentiment analysis. And the first one is known as lexical analysis. So what do I mean by that? In lexical sentiment analysis, we score the sentiment of documents in these notes in the journal, which you'll get after the fact. I just use the abbreviation doc for document. We score sentiment from the individual words in each document, and particularly then when no other external measure of sentiment is available. Like in this example, we have this text from the Beige Book reports, but we don't have any other information that might tell us what sentiment of the person who wrote this report was at the time. And what that means is that we have to make some assumptions about individual words and how they convey sentiment. So we base it on what's called a sentiment dictionary, and you might hear this referred to as a lexicon. That's kind of the official linguistics term for it. And in that, we specify sentiment scores for individual terms. For example, wonderful is a very positive term, so we might say that that's worth positive 90 points. And disappointed, that's a relatively negative term, but not incredibly negative. So we'll say that that gets a negative 30. So then for each document, we take the scores of the individual sentiment terms, or what we'll say sentiment phrases, because you can have more than one word in a phrase denoting sentiment. And we use those to calculate the sentiment of the documents. And we're going to talk about how the scoring actually works very briefly here, but I just want to kind of lay the foundation for how this analysis works before we get started. And so what we're going to do now is talk about how you set up the analysis and then how you interpret and explore the results. And as we're going to see for lexical sentiment analysis, most of our efforts are going to be spent setting up the analysis up front, in particular working on this sentiment dictionary that I've mentioned. So what I'm going to do right now is get rid of this full data set that has almost 5,300 reports and pull up a more abbreviated subset. And I do that only because as we work through the setup of the analysis, I'm going to take some steps that automatically trigger a recalculation of sentiment scores. And as you'll see, especially if you work with your own data, it's actually pretty fast, even when you're working on huge amounts of data. But for our purposes, even just a 1 or 2 second delay when we click things might kind of bog us down in our demonstration. So we're going to go with just about 1,000 reports here. It's actually data starting at the first report in January of 2010 up through October of last year. So sentiment analysis is an option under the red triangle in Text Explorer. And so to get to it, we first want to just launch the Text Explorer platform. So let's go ahead and launch that now. You find that under the Analyze menu. We'll take our text and pass it into the text columns role. Now, I'm not going to spend a lot of time today talking about all the individual settings and features of Text Explorer in general. We have a separate mastering jump that you can watch on that. But for those of you who are already familiar, you're going to notice one thing that I'd like to point out now, and that is our stemming option. So stemming takes multiple forms of a word, say, strong, stronger, and strongest, and collapses them into a single entry for the purposes of our analysis. So all of them would just count as the word strong, if you want to think of it that way. I'm going to leave that off for now. And you might imagine that's because maybe strongest is a little more positive than stronger, which itself is more positive than strong. So we want to leave those separate. So I'm just flagging that at the start here. So when I click OK, JMP tokenizes the text. That is, it breaks it up into its individual words and then counts all the words up. If you are familiar with doing text analysis, really in any tool, or certainly in Text Explorer in JMP, you know that you start by curating the text in a couple different ways. One way would be to declare stop words, that is, words that aren't really meaningful for us and shouldn't be included in the analysis. Let's find a good example here. How about the word since? So this is just kind of indicating temporal structure. And for us, we would say, well, it doesn't really have anything to do with sentiment, or maybe other types of analyses we would do on this text. In some cases, we would add this as a stop word. So I could just right click on it and say, hey, put this on my stop word list. Don't include it in any analyses. But as we'll see, we don't really need to do that for this lexical sentiment analysis we're about to do, because as long as we don't assign it a sentiment score, that is, it's inherently worth 0 sentiment points, then it can be included in the analysis without affecting the results in any way. So I'm not going to bother with the stop words right now. However, we'll see towards the end of looking at this particular form of sentiment analysis that it does or can be helpful to include some phrases. For example, let's say something like real estate. We know that that doesn't really mean what just the word real and estate does. It refers to maybe property of some kind. And so I might want to, in fact, include that as a term for the analysis. And so I would, when doing sentiment analysis, add some phrases like this. And we'll see exactly where that comes into play as we go along. So we won't do any stop words. We would typically do phrasing here. And once we were done, we would launch the analysis, which is found under the red triangle right here on sentiment analysis. If you hover over it, you'll get a little tip that tells you exactly what it's going to do. And it says identify sentiment terms in documents using lexical analysis, which again is what we're talking about here. So I'll invoke sentiment analysis. And you'll see we get a full-blown report out already. We didn't really specify anything up front. And it looks very much like the report that we started with when I showed a couple examples of the Beige Book sentiment. So what I want to highlight here is that even though it looks like we have a complete analysis here, this is just the starting point for our analysis. It's really important to, as I've been calling it, set up our analysis, put more directly, to curate our sentiment dictionary before we actually start looking at some of the scores that we're seeing. So let's talk about the sentiment dictionary, all of our sentiment terms, and how to work with it. So in our sentiment dictionary, we have three basic lists: the sentiment term list, the intensifier term list, and the negator term list. So let's look at each of those in turn, starting with the sentiment terms list. And this is a list of all the terms that we believe carry some sentiment, like, for example, the word wonderful. JMP comes with a pre-built sentiment term list, or again, you might hear the term lexicon. You can see it even includes some emoticons like frowny face and smiley face that are worth -70 and 70 points apiece. And as we scroll down, you can see some additional words like bad, of course, or best. This is a list that can help you get started doing sentiment analysis, but it's very important to go through this list, see if you agree with the words that are there, some of the scores that are there, and perhaps more importantly, even add some words that might be important in your domain. So let's take a look at how we might do that. I recommend looking at your raw text to try to identify some likely sentiment terms. If we go back down to our sentiment summary, you can see that we have a list of documents here with their existing scores given the built-in sentiment term list. And I can just go through the documents here. It's important to actually read some of these documents and see if you can identify some potential sentiment terms that are not present in the built-in list. For example, we read, on balance, reports from contracts for late November through December suggested overall economic conditions improved in the 6th district. We might think that the word improved is generally positive. That is, somebody would only write the word improved if they meant that something good happened. And so I might want to include that in my sentiment dictionary. So luckily, we have some interactive tools that allow you to do that. You can see if I hover right over improved, it tells me improved is not currently a categorized word. That means it's not in our sentiment dictionary anywhere. And I could declare a sentiment score for it. You can see we have some pre-built options here. These buttons, +90, +60, +30, these are the sentiment scores we could assign to this word. So let's say I want to assign a score of +30. JMP now is adding that to the dictionary and then rescoring all of the documents automatically to account for that addition. So if I go back up to our sentiment terms list and scroll down here, we will find the word improved in alphabetical order right there with that score of 30 points. But those buttons, +90, +30, and so forth, those are just kind of starting points, ways for you to quickly drop in something that is, mild, medium, or strong sentiment. And you can always change it after the fact. So let's say I want that to actually be 40. I can just type 40 in and click enter. And again, JMP will automatically apply that new score for me. So I recommend when you're starting with sentiment analysis to read through a subset of your documents, preferably a random subset, to try to identify words that belong in your sentiment dictionary and then add the scores appropriately. Now we have a couple other lists in our dictionary. For example, the intensifier term list. So let's talk about those for a minute. Intensifiers are sentiment multipliers. For example, absolutely we count as a multiplier of 1.6. So that means that if we said something absolutely improved, we would take the 40 points we just gave to improved and multiply it by 1.6 to obtain the full score. And as we saw down in the text pane here, if we were to hover over any term, we can add it as an intensifier with a few built-in multiplier values as well. And finally, we have what we call our negator terms. And these are terms like no, not, or ain't, can't, that reverse the polarity. That is, take a positive sentiment and make it negative, or vice versa. So you can see in this list of terms, we don't have any scores associated with them because it's just multiplying whatever the sentiment score is by -1 to flip that sign. And again, if we see any negator that isn't included in the built-in list that we might want to include, when we hover over any word that would be that negator, we have the option to click the little negative sign here to assign it to that list. So this is honestly, I would say, the biggest part of setting up a sentiment analysis is to read through a number of your texts to curate a sentiment dictionary, including intensifiers and negators that you believe is relevant to your domain. Just to come up with a quick example of how important it is to do this, one of the words, when we look at the full data set, one of the sentiment terms that is most frequent is the word strong, which it turns out economists use in a very positive way all the time. You know, job growth is strong, the economy is strong, and so forth. And so we'd certainly want that to be a positive sentiment term in this analysis. But imagine we're in a situation where we're studying customer opinions about a new fragrance for a perfume that we've created. The word strong might not necessarily be positive there. If people are saying, oh, it smells very strong, I don't know that I want to call that, say, a positive 90. That might not even be a good thing. Maybe at best we'd say it's a wash. Some people think strong smell is good and some don't. And so we want to make sure that we have curated our lists, so our sentiment terms, our intensifiers, and our negators, to fit the domain that we're actually working in. Now, I've shown so far the interactive way of curating these lists, or at least the most interactive, by using the text pane itself at the bottom. But if you go to the red triangle under sentiment analysis here, you're going to find additional ways in which you can manage these lists. So if I click Manage Sentiment Terms here, you'll see, especially if you're familiar with Text Explorer and stop words and phrases, you'll see an interface that allows you to view the built-in list, declare exceptions to that list, that is, remove things from it. What you've also added to your local list, your local analysis, the ability to add or remove words at will. So if you just know that the word strong is important here, you could add it automatically. So I'll say strong deserves a score of 60 and add it to the list. And you can import and export your lists. So if you're going to be performing sentiment analysis on text generated but in the same context by the same types of people over and over again, you can go through this process once, save your list, import it later when you need it, share it with others, do whatever you'd like to do with it. So that's a little bit on curating the sentiment dictionary. Again, I really want to stress how important it is to do that.
The feelings or the sentiments, are they available in other languages?
Yeah, so sentiment analysis right now is available only in English. Though if there's enough clamoring for it, perhaps it could land on the roadmap to add support for additional languages at some point in the future.
Is there a reason, or do you need to normalize, when you were showing the first example, to normalize the data points?
No, there was no need for normalization or anything like that here. I mean, you probably have noticed we're, as I mentioned, on a scale from -100 to +100, but that's just inherently built into the scale itself, so no additional kind of normalization would need to take place.
Is there a minimum number of data points that you need to make the analysis beneficial?
That's a tough one. You certainly would want to collect as much data as possible if what you're trying to do is get a very high level view. So in this case, we have 1,000 reports, and maybe because I have a relatively large number of reports, I can believe that this representation of overall sentiment from 2010 to the present is reflective of the truth. If you were dealing with, say, product reviews, certainly you wouldn't want to just trust the sentiment from 10 or 20 reviews. You might want hundreds or thousands, but it ultimately is context dependent. It depends on how consistent and how strong the sentiments are you expect to find are in the text that you're analyzing.
A couple more came in. Is there a general recommendation on the number of terms you should have in each list?
No, I'm afraid there's no general recommendation. That's where this becomes a bit of an art, because it's all dependent on your exact domain.
Okay. And then another question, can you show us again one more time how you manage the terms? How do you get to that list again?
Sure. Yeah, that list you can find under the red triangle next to sentiment analysis, not the top red triangle next to text explorer. And then you'll find those options down here: manage negation, manage intensifier, and manage sentiment terms.
And let's do one more. Are there particular applications where sentiment analysis is, that default dictionary is amenable to drawing certain inferences?
I always get nervous with words like always and never, but I'm going to go out on a limb and say that it is never appropriate to go with the built-in list, because in any domain, there's at least going to be a few important sentiment terms that you need to make sure you have in there, or just one or two words on the built-in list that you decide actually in your domain aren't appropriate. So I would say you should never do the analysis with only the built-in list.
Let's do one more here. Do the customizations of the intensifiers or negators override the initial, or I guess the dictionary list? Or does it just contribute and add to the overall scores?
To the degree that you make any changes to a term on the built-in list, that will override that. So whether you remove it, whether you change the score you think it should have, that's going to override the built-in list. Same goes for all of the three different types of terms here.
What are the user and column boxes in curating the dialogue? John, if you can provide us with a little more detail. Okay, he wants to know how to manage the terms and customize it. Okay.
I see what you're saying. So these, yes. So it's also possible to specify sentiment term lists or intensifier negator term lists that are applied on the level of the individual user. So when you're logged into your computer, you might have sentiment terms that you have included just for essentially your profile. You can think of it that way. Or you can associate them with the specific column of your data such that you wouldn't even apply this customized list to another column of text. So local here then just means local to this one analysis only. So let's talk briefly about now how the scoring actually works here, and a couple things to know, and then we'll take a brief look at the various ways in which we would recommend you get started exploring the results. So the individual phrases, you may have figured out kind of how this is going to work already. We said that we take a sentiment term score. For example, improved, we said was worth 40 points. If it occurs with an intensifier, we multiply it by that intensifier value. And then if it occurs also with the negator, we multiply the score by -1. So for example, if we had not too disappointed, and disappointed is -60, 2 is a multiplier of 1.2, and the not is worth -1, we would end up with a score for that individual sentiment-bearing phrase of -72. And I've mentioned this before, everything here is capped at a -100 to 100 scale. So if in performing these multiplications, you would end up with a score greater than 100 or less than -100, it will just be truncated there at the limits. So for each document then, we have two different scoring options. The first we call scaled, and this is just the mean sentiment phrase score. So you take all of the sentiment phrases in a document, add up all their scores, then divide by the number of phrases in that document to get the final score. And these final scores are what we're seeing in the histogram here, and also in the overall score column for our documents here. We also have min-max scoring, which is basically the sum of the maximum and minimum sentiments. So let's say the maximum sentiment expressed in a document was positive 80, the minimum was negative 20. We would add those together to get a final score of positive 60. If you would like to choose which scoring system to use, you will find that as the top option under the red triangle. And you can see scaled is by default, and min-max can be chosen if you want it. Scaled is nice in that it provides us a view of the mean or average sentiment, though you might want to use min-max in a situation when really you find it more informative to think about the extremes of sentiment being expressed by an individual, and you don't really care about sentiments expressed between those two extremes. Now, finally, a couple things to know about how this analysis works so that you can use it effectively. First, a term can only belong to one class. That is, it can only be a sentiment term, an intensifier, or a negator. It's probably not going to be too often that you run into a situation where you think a word should be both, let's say, a sentiment term and an intensifier. But if you ever run into that case, just know that it can only count as one. Another one to note is that there is some NLP happening under the scenes here, natural language processing, in particular, determining the grammatical, or to use the linguistics term, the syntactic structures of these sentences that comprise our documents here. So we have, under the red triangle, this parse documents option. That turns this NLP feature on or off. I recommend leaving it on and using it so that the assignment of negators and intensifiers can be more accurate. That is, it can leverage the grammatical structures inherent in the data to try to figure out where does negation or intensification actually apply. And we're going to see a couple examples as we move along about where that comes into play. I mentioned not to include stemming, and I just want to drive home the fact that you don't need to include stemming. In fact, it doesn't affect the sentiment scores. So sentiment analysis operates on the raw terms instead of the stemmed terms, even if you have stemming on. But again, we also mentioned that you wouldn't necessarily want to use stemming in this context because you wouldn't want to collapse across multiple terms like great, greater, and greatest. Those should have different sentiment scores. And finally, know that the sentiment dictionary overrides the existing stop word list. So we talked about stop words at the very beginning. We said that we might go to a word, I think it was since, and say, well, let's just exclude that from the analysis and add it as a stop word. In fact, Text Explorer uses a built-in list of stop words. And if we go to manage stop words, you can see them here. So if I scroll down, we're going to find, if I get to the ends, words like no and not. So it looks like those are stop words, but if you're following with me here, you also know that those are negation terms. So if we scroll down, we can see no and not. Any word that you add to your sentiment dictionary, so any of the 3-term lists, will override the global stop word list that you would find under the top red triangle here. And why is that important to know? That's because sometimes you're going to declare a stop word list because you want to do something, let's say, like a latent semantic analysis. And if you then invoke sentiment analysis in the same window, your sentiment dictionary is going to override the global stop word list, and all those stop words are going to find their way into that latent semantic analysis that you did. So I would recommend when you're using this particular tool, sentiment analysis, to do it in its own Text Explorer window so you don't start to get conflicts between the stop words you want to be applied in one analysis or another. So those are just a few tips to know when you actually put this tool to use for yourself. So let's, no, I saw one, sorry, my attention just flitted over to it. Now's a good time to address it. Why is shouldn't listed twice in negation terms? You may have noticed a few words like that. That's because different text encodings actually have a slightly different character for that apostrophe between the N and the T in something like shouldn't. And so we've included both in the list so that both get detected. So let's talk about exploring the results now that we've talked at length about setting up the analysis. What I'm going to do now is actually pull up the original. So this is the results across all 5,000 documents that we had. And let's just explore these briefly here. There are a number of different elements in this report. And I'll just explain each one as we go here. The first is the sentiment distribution, which is this top bit here. This provides the global view, as we've said. So we see the histogram. I think we get that. Orange is positive, blue is negative. But we can also see in this table a few additional pieces of information, like how many documents were scored and what their mean score was. We can see that broken out by positive and negative documents. So here we have more positive than negative documents, and their score is more extreme. So it seems like the documents are more positive than the negative documents are negative, if that makes sense. And we even have one document that did not receive a sentiment score because it didn't have any sentiment terms from our dictionary in it. So we can use this to assess sentiment at a very high level. To the bottom right, we have the sentiment term list, which tells us all of the sentiment terms that were found in our text, starting with the most frequent. You can see it's sorted by the count or the frequency here. So strong was actually the most frequent in all, and I'd mentioned that earlier. So it can be good to look at individual sentiment terms to see how they're actually being used in context. I mean, you can imagine in, say, consumer research, somebody's saying excellent or terrible or delicious. You might want to understand what about our products or our services are actually being talked about when people use those words. So you can use the interactivity here to kind of dive into that level of detail. To the left of the term list, we have the document list. So that's right here. We've been working with it a fair bit. You can see we have a number of different scores. For example, the positive score sum in a document, the average of the positive sentiments, average of the negative sentiments, and the overall score. So this lets you know how the scores are being computed for each document. And I'll just point out that while you're exploring individual documents and you aren't necessarily sure where these scores are coming from, go ahead and just hover right over the table. I'll have to select the window first. And it will break it down for you. So we can see exactly, we have 16 sentiment phrases here, and we can see that the scores for each individual one and what the average score comes out to be. When hovering for explanations, you can also do that in the text pane at the bottom as well. And this can be particularly helpful if you're trying to understand how some of these scores are being computed. And for that, I'm going to go to a specific example here. Let me just check my notes, which it's row 4,250. So let's go on down to 4,250. Here we are. And take a look at a particular example here. I'll get us off the bottom of the screen. There it is. Okay, so none expects robust sales in 2010. Robust is entered as a positive term here. Very often they say things are looking robust. But here it's highlighted in that blue-purple color, which means it's being counted as negative. And if you look actually here at this list of sentiments found in this document, you're going to notice not robust listed. So here we have this instance of the term robust being negated and counting towards negative sentiment. And you might wonder, well, how is that even happening? Well, if I hover right over it, I'm going to get a helpful explanation for what's going on. And it says that the negation term is applied to the current phrase or subphrase containing the statement. And it highlights that it's that word none before this version or this instance of the term robust that's negating it. And so if you're looking around and wondering exactly how things are being scored, go ahead and hover right over them and you're going to get some helpful information. This also highlights the importance of using that parse documents option. Without parse documents turned on, which again is on by default, and right here, you would find that some of these more complicated constructions like none expects robust sales won't be picked up. So that's the real benefit of leaving the parse documents on. Now, something we haven't talked about at all yet, but to me is one of the most useful features here is sitting above the sentiment summary in this features section. So what the features section does is it finds terms that co-occur frequently with sentiment terms and then allows us to rescore the data. So I'm going to open up features and click search. Now JMP has found, for example, that the term sales very frequently occurs with sentiment terms. So does demand, so does activity, and so forth. So sometimes when we're looking at especially big reports like this, or you're looking at reviews of products that mention a lot of different aspects of your product and you want to just drill down into one specifically, you can. I'll just select sales, click score selected features, and we'll see that now I can get a view of sentiment just with respect to sales. And this is an important consideration for sentiment analysis in general, is to make sure that you limit the domain of the analysis, basically what's being commented on appropriately. So here we can see actually that nearly 2,000 of our, or excuse me, nearly 1,200 of our reports express no sentiment with respect to sales. But we can see that positive sentiment is generally outweighing negative by just a little bit. So that is the features tab. I highly recommend looking at it. And then finally, we have the ability to export our sentiment scores when we are done exploring the results and we believe that we're happy with it. And so under sentiment analysis here, you're going to see the ability to save the document scores, which once I save those back to the data table, you'll see here now we have the score for every document. That's how I actually created those graphs that we started with at the beginning. So that's lexical sentiment analysis, and that's kind of the bulk of what we're talking about today. Derived sentiment analysis, we'll spend a little bit less time on. The question is, how are documents imported into JMP? So to answer that question, I will pull up the next data set that we are going to take a look at here. If I can find it in my minimized windows, here we go. So here is a data set on a different public policy issue. This is, again, real data. This is from the city of Toronto, Ontario in Canada, about a little less than 10 years ago when they were thinking about building a casino and they asked for public commentary on that. So here's our text. How does this text get into JMP? Basically, any way that you can get the text into a supported file format such that you have one row per text. Now, it doesn't have to necessarily come in that way. There's, of course, table manipulation features available in JMP to help you do some of that. In fact, I concatenated multiple columns together to get these. But any way that you can get your data into a supported file format with a column of text values is how you would do that. So here I have a slightly different scenario than we saw before, in that in addition to people's statements about whether or not they support bringing a casino to the city of Toronto, we actually have them indicate whether they are in favor or opposed to that. So in this sense, we have an external measure of sentiment, and that's what derived sentiment analysis is all about. It's about using an external sentiment measure to drive the analysis. So as opposed to the lexical analysis where we just make some assumptions about how words carry sentiment, here we let the data tell us. And this uses a more general tool that's new in JMP Pro 16 Text Explorer, and it's called term selection. And as we'll see, what term selection does is it builds a statistical model of our sentiment measure, and it would help if I could spell correctly. So let's go ahead and fix that before I forget. Our sentiment measure predicted by what's called the document term matrix. It's predicted by the terms that appear in the text, and we'll dive into that in just a moment. Now let's take a look at what this actually looks like in practice. Here's a result of this derived sentiment analysis using term selection. The results look quite similar. We have a distribution of scores where, again, they're color-coded, so we can see the breakdown of positive versus negative. We have a table showing us, how many positive and negative documents we have and how positive and negative they are. We have a list of terms and their associated scores. We have an interactive table of documents and the terms that have been found and how they're scored and all of these things. So you can think of the main difference as how we got here in the first place, and it's by using a statistical model based on that external sentiment measure. That is, whether somebody stated that they were in favor of or opposed to the new casino. So this has a number of benefits, doing your sentiment analysis this way. First, you use data to derive your term and document sentiment scores. So you don't have to make any assumptions on your own, which can be desirable. In doing this, that is having a specific sentiment measure ahead of time, you can rely on a more specific definition of sentiment. Here, it's whether somebody's in favor or opposition of some specific action, as opposed to more general sentiment. And you can also achieve greater granularity in some situations. So if you remember, if I pull our data back here, we're basing this on whether somebody's in favor or opposed to the casino, which is a binary measure, but we know some people are more or less opposed, and we might be able to pick that up in a more granular way by using a model to assign, in this case, continuous sentiment score. Another benefit is we might actually identify some important sentiment-bearing terms that we would miss just by reading some documents or thinking about it. For example, most of these words here are words that we might not necessarily think of immediately as sentiment-bearing terms, but they appear to be related to sentiment statistically. And we can apply the model that we built here to future text, even if that sentiment measure isn't available. So in some situations, to build a model like this, you might take a subset of documents and have humans score them for sentiment, maybe even just saying this one's positive, this one's negative. You can then build a sentiment model that then can be applied to future data when you no longer have people manually scoring them. So let's talk derived sentiment analysis using term selection, kind of how it works and how to interpret the results. So we start with our data table here that has our text and the measure of sentiment that we want to use. I'm just going to get straight into Text Explorer here. Now here, previously, we didn't declare any stop words because if we didn't assign something a sentiment score, it was inherently excluded from the analysis. Here, you may want to declare stop words so that they aren't actually potentially picked up erroneously when you fit the model. So there can be some terms that actually correlate strongly with a term that's predictive of sentiment, and you want that real term returned to you instead of just maybe like the word new, which may or may not necessarily bear any sentiment. So you may choose to add some stop words. And you may also want to add some phrases because, again, some phrases may actually be predictive of sentiment in a way that their constituent words are not. So I would spend some time getting your stop word and phrase lists the way that you like them here. For example, I've already added world class because I think maybe that's going to contribute to some positive sentiment. When we want to run the analysis, we use the term selection option under the red triangle. So we'll find that right here. First, we take the external measure of sentiment we have. As it says here, you can use a nominal, ordinal, or continuous response variable. Know that if you use a nominal variable and it has more than 2 levels, what you're going to do is pick a target level. Here I've chosen in favor, and it will build a logistic model that is a model predicting the probability of that target level versus all other levels. And also know that if you choose an ordinal variable, make sure its data type back in the data table is numeric, because what's going to happen under the hood is it's going to be modeled as a continuous response. So I want to use my terms to predict whether we're in favor of the casino. We have some additional upfront options to specify. So what we're using here is actually JumpPro's generalized regression tool, and we have some controls built right into Text Explorer. So we have a link down here. If you're watching this later and you want to learn more about the generalized regression tool, I'm not going to go into detail explaining it. We have a separate Mastering Jump webinar for it. And under the model settings, you can choose which type of estimation method you want to use and the validation statistic to use. And then you specify some options about the document term matrix that you're going to use. So basically, what you're going to use to try to predict sentiment. So let me bring our table back. You can see right now I just have these 3 columns. Note that we have a couple options here. We have the number of terms. So this is how many terms do we want to try to use in maximum to predict opposition to the casino. And then how do we want to weight those? Binary just means, does the text contain that word or not? And there are some other weightings as well. And so what's really happening is JMP is taking the document term matrix, which you can see we save here. Let me just save the top 100 terms with binary weighting. And so you see I have a bunch of columns now where we have a 1 if that document contains that term and a 0 if it doesn't. So here, let's say for jobs, if we select the 1s, here are all of the texts that mention jobs. And so we're just using those as the inputs to the model, and then the variable we're predicting is opposition. So I'm going to run the analysis. JMP is calling out to generalized regression to, in this case, build an elastic net model. And once it's done, we're going to see that output that we started with, where in this case, the sentiment scores that are being predicted are, in essence, the probability that somebody is going to be in support of the casino. So here's where we started with our analysis. We can see some information about how well the model fit. So we want to make sure we have a good fitting model, and I'll point you to the mastering on GenReg to help you figure out how you decide that. Just know that at the top, you have access to the full generalized regression platform to be able to make use of all the options to try different models to find one that fits best. So now that we have our results, let's just interpret them briefly here. The top level summary, as we mentioned here, is similar to the sentiment analysis tool. So we have the histogram and the table telling us about the kind of high level summary of our sentiment. You'll notice that we have this word contribution instead of sentiment score, mean contribution, documents with net contribution. It's actually popping up in a lot of places. This is just saying, essentially it's a generic term for our response scale. And with the logistic model here, that means the log odds scale. We have the contribution values for each document in this table down below. And if we hover over any of them, you can actually see that it's just, in this case, the sum of the positive or negative terms that appear here. So each one having its own contribution to the sum total. And then, of course, for our ultimate outcome, we can see the probability that someone is in favor of or in opposition to the casino. The term coefficients to the right here are interpreted just like coefficients from a regression model, in this case, a logistic regression. So here we have our coefficients. Jobs has one of 3.091, which means that the log odds of supporting the casino goes up by 3.091 points if somebody mentions the word jobs or not. Finally, we have the log worth. This is a transformation of the p-value. So we're basically doing a regression analysis here, which means we get a p-value associated with each of the predictors or terms to help us decide how statistically reliable the finding of this term is. So we can even sort by any of these columns to see that, oh, it looks like one of the most reliable findings is the negative contribution of the word addictions here. But to zoom back out, we're interpreting this much like we would interpret any regression model. We're just using it to, in this case, score documents for sentiment, where we started in this example with a binary measure of sentiment, and now we have a more continuous measure, and that's just one of the potential benefits of doing a derived sentiment analysis like this. Finally, if you want to use this model to score new documents, you could go up to the term selection red triangle. You can save the scores or even save the prediction formula to your data table so that that formula is now portable, and you can apply it to a document term matrix extracted from new data using Text Explorer to generate some new scores. But to zoom back out here, we've covered two different ways of conducting sentiment analysis: lexical sentiment and derived sentiment analysis, where the difference is whether or not you have this external measure of sentiment. But in either case, the big benefit is that now in Text Explorer and JMP Pro 16, you have some great tools available to you to be able to, from free text, determine the degree of positive or negative emotion that's being expressed.
can we use the derived sentiment on another data set, and can it be saved out as maybe a function, or how would I go about using that against another analyses?
So that was this option for save prediction formulas. So I've actually checked it now and it's writing that to the data table. And then we'll pull the data table back up to see what's happened. So here it's being populated as we see. We have the probability of being in favor. And if we look at the column formula, you can see that we have the model formula here, as you would save any others. Just know that that formula operates on the document term matrix that we're seeing to the left. So to score new data, you would want to load those data first into Text Explorer, extract the document term matrix, and then feed it through this column formula to get your scores out.